Hello, Mr. Wilmot here, and today we're going to talk about Ohm's law. The first thing I want to make sure you understand are the terms directly proportional and inversely proportional. So directly proportional means that one quantity increases, causing another quantity to also increase. For example, the number of hours you work and the amount of money you make are directly proportional. So at least if you work on hourly wage, the more hours you work, the more you get paid. Inversely proportional is the opposite. While one quantity increases, it causes another quantity to decrease. For example, speed and travel time are inversely proportional. The faster you go, the less time it takes you to get there. So Ohm's law itself states that current is directly proportional to the voltage and inversely proportional to the resistance. The mathematical relationship between current, voltage, and resistance is basically if you know two of the three quantities, you can solve for the third. Later on, not in this video, we'll do a lab where we raise our resistance and you'll be able to see that inverse proportion where both your voltage and current will decrease. I'm going to place this chart here as a reminder and for your reference. The abbreviations for voltage could be V or E. For the purposes of this video, we're going to stick with V. Current is with an I and resistance with an R. They're measured in volts for voltage, amperes for current, and ohms for resistance. And then there's the symbols for each of those. V for voltage, A for amps, the omega symbol for ohms. And here is the formulas. Current equals voltage divided by resistance. Voltage equals current times resistance, and resistance equals voltage divided by current. If you understand how mathematics work and how these formulas work, you'll see how the proportions work out. But I'm going to show you a chart that'll help you remember which formula to use and when. So put this little circle chart down, either in your notebook or on a piece of paper. You'll draw the circle with the V on top, a line through the middle, and a line going halving the bottom half, with an I on the left or an R on the right. You could flip those around. You could have the R on the left and the I on the right, but that's not really important. What's important is that the V is on top. So if we want to solve for V, we'll use our chart and we'll take our finger or our thumb and cover up the V. What we're left with is the I and the R, and we're going to multiply them. They're right next to each other. So to solve for V, we're just multiplying I times R. We're covering up the V, we're multiplying I times R. If we want to solve for I, we're going to cover up the I. What we're left with is V over R. So to solve for I, we have voltage divided by resistance. Hopefully you can see where I'm going with the next part. When we solve for R and we cover up the R, what we're left with is V over I, or voltage divided by current, to give you your resistance. So here's an example of a simple circuit. We have a power supply on the left-hand side that's labeled as 36 volts and a resistance of 1.8 k ohms. What we want to do is solve for current. Our current is currently unknown. So using Ohm's law, or if you use your chart, and if you cover up the I, you'll see that what you're left with is V over R, so voltage divided by resistance, which in this case would be 36 volts divided by 1.8 k ohms. And if you remember your SI notation, 1.8 is not just the value 1.8. it's 1.8K, which is 1,800 ohms. If you use your calculator, you'll get an answer of 0.02, in this case amps, because we're solving for current, which again, using SI notation, is better written as 20 milliamps. So here's another example. I want you to pause the video and practice using these values. We want to solve for I, and we have our voltage of 25 volts and our resistance of 10 ohms. So using Ohm's law, or the chart that I mentioned, if you cover up I, you're left with voltage divided by resistance. So again, try it first, and I'm going to show the answer now. You should get 2.5 amps. So here's an example for calculating resistance. Here's a simple circuit with a power supply of 24 volts and a current meter of 30 milliamps. To solve for R, if you use your charts and you cover up the R, you're left with voltage divided by current, which in this case would be 24 volts divided by 30 milliamps. Again, remember that 30 milliamps is not 30, it's really 0.03 if we take it back to base units. If you put everything in your calculator correctly, you'll get an answer of 800. In this case, it's 800 ohms because we're solving for a resistance. Here's another example. Again, I want you to pause the video. We have a value of 26 volts and 1.3 amps of current. To solve for R, using Ohm's law, we would divide 26 by 1.3, and the answer is 20 ohms. Here's our last example. Here we have an unknown voltage on the left-hand side. We have an amp meter reading 150 milliamps and a resistor or a resistance of 270 ohms. So using Ohm's law, if we cover up the V on our chart, we're left with I times R, which is current times resistance. In this case, 150 milliamps times 270 ohms. And again, remember your notation. You're not multiplying 150 by 270 because it's 150 milliamps. So what you're typing in your calculator is 0.15 times 270. You would get an answer of 40.5 volts. Last practice example. Here we have our values of our resistance and our amps. We want to solve for V. So again, pause the video and solve using the two known quantities of 1.2 amps and 15 ohms. I'm going to show you the answer now. And that answer is 18 volts. So hopefully you were able to get all three of those examples right. Make sure you understand the formula or formulas, how they work, and use the chart for reference. There's nothing wrong with that. Until you can memorize the formulas, there's no shame in using that chart. Okay? Thanks for watching my video, and have a good day.